Thanks.
Okay, thank you, Charlie. Thank you all for being here today, this morning for you, this evening for me here in Spain. And this is a very special thanks to Charlie, because I've had many invitations to talk about these issues before, but usually it's from from organized societies or institutions or libraries. And I can't really remember a time when a PhD student sent me a personal invitation out of pure interest to share thoughts and discuss with colleagues about these topics. And I think this is a special, so that's why first I'm very flattered that he chose me for this talk. But apart from that, I think organizing this out of his enthusiasm for these topics is something that really should be also acknowledged and appreciated by all of us in the department and all his colleagues. So thank you, Charlie, for this invitation. And so Charlie asked me to provide in this talk a context for the following discussion, a context about academic publishing, what's new things that are happening in academic publishing that perhaps we researchers should be aware of, and in order to make better decisions about the ways that we do science also, but also the ways that we communicate science. So I will try to do just that, just provide in this hour that I have for this talk. I try to be as brief as possible so that we can have more time for discussion later, which is I think the most important part maybe. So in this hour that I have, I will try to offer this context, historical context, and also conceptual context about what's going on, where all these new things, new developments are coming from. We hear about preprint servers, we hear about open access. Now it's you have to pay for open access, and there are also mandates from funders, from institutions to publish in open access journals. There are also expectations or sometimes even mandates for sharing data and code. So many things going on, new initiatives that are promising to save the world and change science and make it more open, more transparent. So where is this all coming from, and where is it going, and how should we be, what should we know as researchers to navigate this new landscape? So this is the idea of this talk. Charlie said that he will also put this online. I will also share the slides through my blog, and I'll also send it to Charlie if he wants to put it also online. People who are on Twitter, this is my handle here, so you can use it if you want to continue the conversation later online. To offer this context that I'm talking about, I will discuss about what I think is a problem, what I think is a big problem. I'm probably most of you are aware of this nice anecdote with blind people trying to describe a problem, and for each one of them it's different because they view it, they see it, they don't see it, they touch the elephant from different angles. So the same thing is happening with the problem that I wish to define. So instead of trying to give one only perspective of the problem, I will adopt a process-based approach to define the problem. So this is something that we use also in, I assume that some of you or most of you maybe are psychologists in psychology, in clinical psychology. Sometimes now we talk about process-based therapy, or we stopped talking about problematic processes like interpretation of somatic messages, things like that. So I'm going to try to use a similar approach to find processes that are very important for scholarly communication, for research, for science, and see how we do this, how these processes are performed in the current model, and whether there is some way to improve them. Because as you will see, I'm quite convinced that the way that these processes are handled is quite problematic. So let's see what I'm talking about when I mention these processes. These are three: validation, evaluation, and dissemination. By validation, I mean the process through which a research product, let's say a scientific paper or any scientific result, is validated, gets some seal of approval. So that we know that, for example, it is methodologically sound, that it's that interpretations are based on sound theories. So this kind of quality certificate. This is what I mean by validation, which is, I think you will agree with me, very important for science. We also have another process that it's very important, which is evaluation. This refers to some kind of quantitative metrics that we can use in order to evaluate different scientists, compare scientists. It's a necessary evil, perhaps, but it is necessary because we need to know how to hire, how to choose who to hire for positions, how to allocate funding to different projects. So we need some kind of quantitative metrics to evaluate research. And then, of course, the process of dissemination. Once the research is out of the lab, it needs to be shared with the world, not just the academic community, but also the public. So I will now, if we agree that these three processes are important, I will invite you for an exercise of imagination and try to think, if we forget about how these processes are performed in the real world today, how would we want them to, how would we design, what kind of model would we design to handle these processes in the most efficient, let's say, way. So let's think about validation. You know, sometimes I really do this exercise when the situation allows it, when it's more face-to-face, and we have some time. Sometimes I let people like write down ideas about how to validate, evaluate, and disseminate science, and I can assure you that all the ideas that come up are better than the system that we actually have, and which is really interesting in itself. So in this now I will go through what I think would be an ideal way to arrange these processes. So, for example, for validation, I guess you would agree that we would want as many reviewers reviewing and validating research, as many as possible, and it would be preferably they would be experts in the topics that they are reviewing. And of course, it would be very important not to have any conflicts of interest. And another thing, a third thing would be to have access to their argumentation. Maybe it's not enough just to hear that these expert peers approve this research, but it would also be interesting to know what were their comments and what were their objections in case there are some objections. So how about evaluation? Here, if we think about how would we come up with quantitative metrics, we can see that there is an agreement between validation and evaluation. We think I would say that we would like the same people, the same expert reviewers that are validating research, that they would also provide some quantitative metrics, because after all, they are the people who actually will have to read the research and will have to express an opinion. So why not ask these same people to also offer some quantitative indices of quality, instead of now we will see what instead of this method, what we're doing today. So this is about this validation and evaluation. How about dissemination? Dissemination, the process of dissemination has changed a lot with the internet and with digital, with research and all research output becoming digital. But still, it's not dissemination. We should be aware that dissemination just doesn't mean to upload something on the internet, but it has to ensure some other things as well. Preservation, digital preservation. We have to be sure that the content that it's being uploaded on the internet will be permanently accessible. Licenses are very important. We need to know that this work will be not just accessible, but other researchers, other scientists will be able to build upon this, use it and build upon this work. This is what science is about. And of course, visibility is also important. Here, I would add that there are some, now with algorithms, with machine learning, with artificial intelligence, it's also important that research is not just accessible as a PDF, for example, but also in formats that can be accessed through algorithms and machines to do data mining and produce new knowledge and combine perhaps knowledge from different research outputs. So all these things are what we expect from a proper efficient dissemination process. So if now we jump to the current model, how we do this, how we handle these processes in today's academic publishing model, we will see that validation is performed by 2 or 3 reviewers who are usually anonymous. We don't know who they are, so we don't know if they're experts. We assume that they are experts. We assume that there are no conflicts of interest, and we have no idea about why they feel that this research is valid or not, because the reviews are disclosed to the public and to the community and the public. So about evaluation, what kind of metrics do we use for comparing, for assessing, for ranking scientists and scientific projects? We use citation metrics, mostly the impact factor, or we use directly the journal prestige. And now there are some alternative metrics, but still they're based on based on citation. So they're still based on the usage statistics based on the journals where the work is published. And about dissemination, how do we handle dissemination? Our work is published in mostly private publishing companies that keep them in private servers. They use restricted licenses most of the time, even if it's open access. This is not just the end of the story. Open access is not just doesn't include what I've been discussing earlier about permitting not just users to download the PDF, but also machines to access the research, and also or even humans, authors, researchers, to build upon it, reuse, modify, and build upon this research. These licenses, even if something is open access, doesn't mean that that the publisher offers this kind of facilitates this kind of access. And about visibility, yes, there is visibility, but we have been always paying for this visibility. Now that we're switching slowly to pay to publish open access model. We will talk about the different models later. We become aware of the amounts of money that we pay for this visibility. But even before that, even when we didn't have to pay any money as authors, we were paying because our libraries were paying. So this visibility, maybe it's accomplished through this model, but at a high cost, as we will see. So if we see really what is happening now today, we see that all these essential processes for science are totally journal dependent, because all these processes are happening at the journal level. The validation through peer review, citation metrics, we're using journal prestige, journal metrics for evaluation. And of course, dissemination access is provided through these journals as well. So something that is really natural that has happened. I mean, otherwise it would be really a surprise would be not to have happened in this way, is that this absolute dependency on academic journals created a mercantilization of the academic journal, and they created a market of academic journals. And as soon as a market with such a dependency was created, the next expected thing that happened was mergers. Like big publishing houses bought more and more journals. They became even bigger and stronger, made a very wider portfolio of journals. They became really giant firms, and they had also, based on this dependency of our community of research of science on journals, they made it possible. This dependency made it possible for these firms to extract higher and even higher journal prices from university libraries. This is something that the economics of this model is something that I discuss in more depth at this post here at the blog of the London School of Economics back in 2008. So there is a lot of money involved. We're talking about giant firms with big publishing houses, accumulating more and more journals and selling them to our academic libraries. For how much? How much do really these journals cost? So here are two. I tried to find this also for NYU, but I couldn't find the breakdown of the budget. I don't know if it's public and I just didn't find it, or if it's not public. But for two public universities in Spain, here are the numbers. University of Granada, which is kind of smaller. These are two universities I worked in. This is my current university, Complutense, that pays almost 3 million euros per year, just 1 year, for access to digital content, to digital academic journals. And the University of Granada, a little over 1 million euros. So this is the amount in case it's not. You didn't have access, or you didn't have an idea about the figures we're talking about. This is the money that one university pays each year for open access to journals, access for their researchers. Okay, so this is the money that they pay, so their researchers through their university, by logging into the university, they can have access to this material. So where does this money go? Why do we pay so much for journals? If we look at one of the main publishers in the market, Elsevier, we see the figure of the evolution of their profit margin. This is not income. This is not gross income or anything. It's just the profit margin. So this is what goes directly to the pockets of the shareholders of Elsevier through the years. So we see until it's 2011, but now we'll see that this continued to grow after even 2011. We're above 30%. So I will put this now into context so you can understand whether it's high or low, this kind of profit margin, in case you don't have an idea already. So to see if these profit margins, to compare them, to have something to compare them with, here is a data from ranking different companies from different, all sorts of companies from different markets based on their profit margins. So we see here in the 5 first places, we see 3 publishers in red. These are the bars in red. These 3 are publishers. The first place, 37% of profit margin for Springer. Second company is Microsoft with a smaller profit margin than Springer. Then we have Elsevier, another publisher. And then we have Google. Google has less profit margin than Elsevier and Springer. And then Taylor & Francis, again, another publisher. And we see companies that we all know, and we all would assume that they were making a lot of profit. And perhaps it's surprising that they make less profit than publishers like Disney, Apple, and so on. So you can see an idea, like putting this into perspective, how much publishers earn from this, how profitable is the publishing industry. It's the most profitable industry, basically. And what do publishers, what do publishers do with this money? What is the modus operandi? How do they work? What is the idea for publishers? Publishers, obviously, they're commercial companies. Their interest is in making profit. And here we have an extract from the financial statements of Elsevier in 2018. And here just 2 phrases. We see again that the profit margin is even higher than the figures that we saw, 37.1. And we see 2 statements that give a good idea about how these companies work. In 2018, we made 3 small acquisitions, the mergers that we discussed earlier, in support of organic growth strategy. Here are companies that have been integrated into Elsevier and disposed of a minor pharma business in Japan. So we see that there are companies that they're not just in the publishing industry, but they expand into other areas such as pharmaceutical companies. So it's one of those industries has their own strategic plan for growth. But their main customer, as we see, are the scientists, is the publishing of academic papers. Our customer environment remains largely unchanged, and we expect another year of modest underlying revenue growth. So despite of all these innovations, all these things that are happening in the publishing business, Elsevier is continuing to grow, and not just Elsevier, all these 5 big publishing companies are continuing to make, they're not affected by all these innovations that we're going to discuss about very soon. On the contrary, they continue to make ever-growing profit margins. So is the problem that some people are making ridiculous amounts of money from our product, from our research products? This is not, maybe some people will get furious about that, but this is not the real problem. It's not just that some people are making money. Maybe they're just smarter than us, so that's good for them. The real issue is that in order for this to happen, they had to make, we all contributed in that, to make knowledge a material, to treat knowledge as a material good, which knowledge is something totally different. The example we can use is that if we have something material, if I have an apple and I give it to you, then I no longer have this apple. But if I have an idea and I share it with you, we both have the same idea. So applying market economics and scarcity economics to knowledge is not to the best interest of science and knowledge itself. And this has, the fact that this has happened in order to make profit is exactly what we are suffering, is exactly what is causing the symptoms, some of which I'm going to briefly mention, and I'm sure that you will recognize many of them because you already faced them independently of the stage of your career. But here, for example, in this blog post for your scientists, I argue that the most affected by this model and the symptoms of this problem, or this disease, if you want to call it like that, sometimes I do. The most affected are early career researchers. Sometimes I think we all enter into this business of doing science with enthusiasm. We want to create knowledge, we want to share knowledge, and we soon find out that actually what we need to do is publish more and more papers. So let's see some, like briefly, some things that we suffer in our everyday practices while we do science. Subscription fees. We will talk about subscription fees and open access later. We accept that our papers are not immediately, will not immediately reach the public, but they will first remain locked in the drawers of editors until they decide that they are suitable for publication. And sometimes I collaborated with economics, and the waiting times, for example, in the discipline of experimental economics is an average of 2 years. So imagine after 2 years, it's very normal that you receive a decision from the editor that your paper is rejected. And then 2 years later, you have to start and submit to another journal. So this is really, really crazy. The rights. We grant publishers the rights to disseminate and make profit of our work, obviously. We offer our services, it's a subsidy actually. We offer our review services for free without getting any academic recognition for this. Another really crazy thing is that all the qualitative information that reviewers can provide, the reviewers, they actually write reviews. They offer argumentation, they offer comments, they explain their decisions, but all this is lost, and it's reduced to a yes or no decision by the editor. So all this richness of context, all the work of the reviewers is lost in the system. Rejection rates. As I mentioned, 2 years later, you get a rejection, and then you have to look for another journal. You have to reformat your paper according to the guidelines of a different journal. All this is lost time that we have to suffer just because of the system that we have. it's to our interest to split our research into many different papers. The more, the better, usually. So this is another thing that is totally contrary to common logic and common scientific logic of how research should be packaged and disseminated. Ridiculous things like that I had to suffer as well, like let's not add color to this figure because it's 1,000 euros more for if the figure is has color. Compress the method section, you have the guidelines, each journal's guidelines. So sometimes the method section has to go at the end and find letters and all the important things, supplementary material, or not at all. So this is very important information that we're depriving of we're depriving the public of important information for reproducibility. So here are some other things adapted to tastes of journal editors. Negative results. Who is going to publish our negative results? Most of us, we throw them away. We keep them in the drawers because they're not publishable, or negative or null results. And of course, reviewers, again, with the current review model, we miss the chance to collaborate with reviewers. We don't know who they are. Maybe they offer a very good idea of how to improve our paper, and it would be interesting to know who they are so that we can collaborate with them or ask for further guidance. But this is not possible because of anonymity. And then finally, we feel obliged to investigate the topics that are hot and sexy, more interesting for journal editors, because finally our end goal is to get a publication, to get published by a prestigious journal. So these are just ideas of things that perhaps ring some bells, and maybe you have others to share. Maybe it would be nice to hear some more in the discussion. So next, let's. This is so ridiculous that it begs the question: how come we haven't come up with some better model, and how are we stuck with this way of doing things? I will argue that the first thing that the first element that glues this problematic model together is peer review. So this model is highly dependent on peer review. And talking about peer review, I will go briefly through some facts regarding peer review and its efficiency in the way that it is performed today. First of all, here's something very interesting. I really like this quote. It's from Einstein, just to show you that peer review is not something that we should take for granted. It started in the 50s and 60s. This is what Einstein sent to an editor once, because he was surprised that the editor sent back the reviews of his article, and he says, "I didn't send you my paper to review it. I sent it for you to publish it." And I see no reason to address, in any case, the in any case erroneous comments of your anonymous expert. So it hasn't always been like that. Peer review is something that started after the increase of research productivity in the 50s and the 60s, and before that, journals were not responsible for validation. And now that we have peer review, now that the journals perform peer review in this way that we all know, mostly from through anonymous reviews that are disclosed to the public. So this has been hardly criticized. Here is the editor of the Richard Smith, the former editor of the British Medical Journal. So he says, I'm quoting from what he wrote in 2015, a process at the heart of science is based on faith rather than evidence, and vested interests keep it in place. In reality, it's ineffective, largely a lottery, anti-innovatory, slow, expensive, wasteful of scientific time, inefficient, easily abused, prone to bias, unable to detect fraud, and irrelevant. So it's quite harsh criticism. And it's not just personal opinions. Here we have systematic review of editorial peer review for improving quality, and we see the conclusions of this Cochrane review is that there is little empirical evidence to support the use of editorial peer review as a mechanism to ensure quality of biomedical research. This was focused on biomedical research, but I would expect that this would be similar in other areas as well. Another piece of evidence that peer review is not working as it should is the rise of retractions. This is a paper published in Nature, showing that we see here a rise, a very alerting rise of retractions starting from 2001. And if we analyze the reasons for these retractions, why these paper are retractions, we see that mostly it's misconduct. We have, of course, honest errors and other reasons, but the percentage of misconduct is very high, is alarmingly high. And of course, this is, again, not surprising, because since we have a system that allows gaming and it's so publication pressure is so strong, it's something that we should expect, that researchers will do anything they can at some time to get their papers published. So this, again, it surprised many people, but if we think about it under these terms, it shouldn't be that surprising. Again, we see that the reasons for misconduct, plagiarism, fraud or suspected fraud, there are errors, but fraud or suspected frauds, here we see it's the most common reason for academic misconduct and for retracted scientific publications. In psychology, we've been accused that our science is not valid because it's not reproducible. So we heard that, and if it's true, then I think peer review is also something that we, and the system in general, is something that we should also blame as part of the responsibility, because maybe we'll discuss later about this, or maybe in the discussion if you're interested, but peer review can have a different meaning. It's not just about deciding of whether something should be published or not. But the peer review is really an opportunity to check the quality of the article. But what does quality mean? Quality is really tied also to reproducibility. So we can imagine an alternative system where peer reviewers would also assist in testing the reproducibility of research, so that this result, this question, this publishing of irreproducible science, or at least irreproducible, but also there's a lot of science being published without providing the means to test its reproducibility, which is another issue, again, that the current system, an improvement of the current system should treat. But just not to take all the blame on ourselves, psychology is not the only area that has been accused of low reproducibility. We see that there has been other studies showing that 85% of preclinical studies could not be replicated. Again, this says something about our process of validation of scientific research that gets communicated, gets shared with the rest of the world. Here's a fun research by a colleague in Madrid, who is collecting anecdotal cases. He's collecting cases of Nobel laureates that the papers have been rejected by academic journals. So peer review is not just sometimes unable to detect bad research, but good research as well. It's a very interesting paper, fun paper to read. We even have interesting data here that the reproducibility, here now we focus on clinical neuroscience, reproducibility is not, the agreement between reviewers is not greater than we would expect by chance. So again, this shows that peer review, probably there is something that we can do to improve the way that we validate research. With this brief overview of data about peer review that I think are going to be useful in the arguments I'm going to present later. Let's move on to the second factor, the second process. You remember it was evaluation. For this, I have to say very little, because some maybe 15 years ago, I started giving workshops on the impact factor. But when you hear workshops about the impact factor, I still hear today that I get invitations to participate in workshops for about academic publishing, which is really how to publish and how to publish in prestigious journals. So you can imagine probably at my workshops were very, were kind of the opposite. I was trying to show with a group of colleagues that we were doing that together, I was trying to show how the impact factor is actually useless for evaluating single articles or single academics, and to show how, again, it can be gained both by editors, by reviewers, and by authors themselves, and so really expose all the weaknesses and all the absurdity in using this metric. So I'm not going to go into depth here. I'm just going to show two distributions that I think tell the whole story. This is a distribution just picking 3 journals, but this is actually happening in any journal that you may wish to pick. So this is the distribution of citations per journal. So if we look at any journal, we see a very skewed distribution, which says that out of all the articles published in the journal, the majority of the articles have 0 citations, few or 0 citations. There are only very few articles within a journal that attract a lot of citations. So even if you have published, what does this mean? Even if you have published in a high impact factor journal, like let's say Nature or Cell or whatever, most probably your paper has received 0 citations. So does this make it a good paper with 0 citations? Is it reasonable for the paper to inherit the impact factor of the journal, which has been accumulated, has been produced by other papers, by a handful of papers that have been published there? So this makes it, I think, pretty clear that you cannot use impact factor to evaluate single papers or authors. And then again, another skewed distribution about these are journals, all the journals, impact factors from 74 to 2001. And here's another skewed distribution that shows that there is a high competition. This is the journal monopoly, actually. It shows that there is a high competition for publishing in prestigious journals because these are very few. There are most journals have very low impact factors, and there are only a few journals, and in some disciplines there's just one, or there are disciplines that don't even have high impact factor journals. So you can imagine that this skewness, the skewness of this distribution is evidence that there is a strong competition for publishing in these very few journals that can help you to succeed in your academic careers. So what's happening? What are we doing? What is the community doing? What researchers are doing? What is going on? If there is any effort at all to treat this problem or this disorder, however you want to call it. Mostly what we will encounter are ways to treat symptoms, like all the things that we mentioned earlier, the things that are going wrong in our everyday lives as researchers. There have been many ideas about how to treat these symptoms. But as I will argue later, there is very little done. There are fewer ideas on how to address the core of the problem. So how have we tried to address some of the symptoms? The first symptom that became evident and infuriated the research community was closed access, was the fact that our libraries paid to get access to the products that that have already been funded, mostly through public funding, but our libraries had to pay again so that they get back access to this content. So this gave rise to a movement that was crystallized in 2002 in the Budapest Open Access Initiative. There was a group of researchers, also small publishers, and also funders who demanded open access, said that this is not possible anymore. We have to change the model. We need to have open access to the world scientific knowledge. And let's see what they meant when they talked about open access, because this is very important. This is a very crucial point. When open access, actually, this term was coined in this meeting in Budapest. The term open access, we mean it's free availability on the public internet. permitting any users to read, download, copy, distribute, print, search, or link to the full texts of these articles. Crawl them for indexing, which is what I've been discussing earlier. Providing open access just to a PDF is not what open access is about, obviously. Pass them as data to software or use them for any other lawful purpose without financial, legal, or technical barriers. So this is the definition, the original definition of open access. And you see that it includes things that are important, like being free, being on the public internet, and permitting all sorts of different types of access. So it went one step further, this initiative, and suggested ways to achieve this kind of accessibility. And it suggested two main ways. The first, as you see here, is self-archiving. And the second one is open access journals. So what are these two ways? Self-archiving means that providing open access, like the open access is provided by researchers themselves. Researchers, when they have produced, let's call it let's continue with the paradigm of the paper. When they have produced a paper, they should immediately self-archive it, upload it to some kind of open access repository. This immediately ensures open access because the entire content, all the product, all the research product is available, and depending on the open access repository, fulfills all these requirements according to the definition through these open access repositories. The other way is to publish it to a specific journal that, again, is free, offers free access, and permits all this kind of types of access. But you see, the first way, the first road for open access, actually these were called the roads to open access, and this was termed the green road to open access, and this was termed the gold road to open access. So two different ways to achieve open access were defined, but here we see what happened. Something happened in the way, and things got really messed up because it's really easy to understand why. And in order, instead of me trying to guess or trying to convince you, here are the words of Joseph Esposito. He was a very famous publishing consultant, and here are his words published in 2013, saying that green open access, the whole story of self-archiving, authors self-archiving their articles, has no promise of delivering augmented revenues to the publisher. But gold open access opens up a new customer, the author, him or herself, who in many instances pays for the article to be open access. Gold open access, in other words, represents a business opportunity, whereas green open access represents a business problem. So this makes it obvious that green open access is a threat to the publishing industry, as like a lethal threat, and gold open access is a golden opportunity, actually, to transform, to even increase their revenues by combining the two roads, having both subscriptions, meaning libraries paying for open access, and the authors themselves paying for open access in other journals. So we said that the publishers is not, we're talking about big and powerful firms with very strong lobbying, and there is a very clear evidence of this lobbying by the way open access has been interpreted by countries, by governments, by funders, generally by those who issue mandates, and they show they control more or less where things are going. So here's just one example, but there are many. In 2012, a report commissioned by the UK government was published, the Finch report. And here, again, I'm going to read because it's very clear what is happening. A clear policy direction should be set towards support for publication in open access or hybrid journals funded by APCs as the main vehicle for the publication of research, especially when it is publicly funded. So here we see that there is no mention of green open access. It says clearly, explicitly, that publication in open access journals or hybrid journals, that hybrid journals are the journals that are libraries pay for them and also authors pay for them. funded by APCs, article processing charges, as the main vehicle, because they are aware that there is another vehicle, which is green open access, which is not mentioned at all. So the main vehicle will be publication in these open access journals. And what are the key actions that are being recommended? Make clear commitment to support the costs of an innovative and sustainable research communication system with a clear preference for publication in open access or hybrid journals. You see the wording here, commitment to support the costs. This is why now we get part of our research project money is directed to gold open access publications, because the lobbying of the publishing industry has made it this way, has convinced funders that this is the way to go. They have to support the transition to open access, to bring up to gold open access, with a clear preference. Again, we see that they are admitting that there are other ways, but there should be a clear preference for publication in open access or hybrid journals. One second, I need to connect my charger here. Okay. So you see that I'm calling it an open access and missed opportunity, because really when we tried to solve the problem as a community, we tried to solve the problem of open access. What we tried to solve was just a symptom of the problem, and it's treating symptoms is not the way to go. And we see that the result has been that the publishing industry obviously continued to sustain their model despite this effort. Again, there is another player in this system that again is trying to treat another symptom. These are the preprint servers. You probably recognize some of them. We have also PsyArXiv in psychology, provided by OSF, by Open Science Foundation. So these preprint servers, supposedly they are there in order to treat the symptom of late access to academic work. So as we saw, one of the symptoms was that when our research is ready, we cannot share it immediately with the world. We have to wait for the acceptance of a journal. So this is one of the symptoms. It's problematic. And these preprint servers appeared in the landscape to try to treat this symptom. But there are some problems here as well, because I'm discussing particularly about bioRxiv here in this blog post, because open a brief parenthesis here. bioRxiv is a preprint server, but has a policy of not accepting to update the final article that once it's published in a journal. So maybe I'll keep this parenthesis for later, because I think it would be easier to understand what's the problem with these initiatives, with these preprint servers, after we've seen the alternative that I'm going to suggest very soon. Yeah, I'm running out of time, but I think we can make it. So there's another thing that is really, for me at least, really scary and troubling, is the alternative publishers. Every now and then we have PLOS, we have Nature Communications, we have big initiatives that are promising to do everything right. Like eLife now is offering very innovative peer review model. Reviewers are acknowledged, the reviews are published, and all sorts of comments are also published. So everything looks very nice and modern and the way it should be. So it's a very nice treatment for some of the symptoms that we discussed. What is the problem? Here is in 2016, eLife is being funded by funders, and it has a very serious sustainability issues like any private initiative. So we see that in 2016, instead of publishing for free, they started publishing for free. In 2016, they established a fee of $2,500 per article, which is on the high side in the market in general. In 2001, just a couple of months ago, as we approach our third round of funding, our funders wish to focus the investments on developing new approaches to research communication, such as work on a SciET and executable research article, no longer subsidize the basic operation of the eLife journal. We are therefore increasing our publication fee from $2,500 to $3,000 effective April 5. So we see when the solution is coming again from private companies, we again have the same issues of conflict of interest. When the time comes to make decisions about what's good for science, the priority is not science. It's not how to perform these processes in the best, most efficient way. The priority is profit, or at least sustainability, as we see here in the example of eLife. The same is happening now with those Open Science Foundation. They started providing their servers, PsyArXiv, for example, and PsyArXiv, archives that are preprint servers that are closer to us, psychologists. They started offering them for free, and now they start to charge the communities that are running them and managing them. They start to charge since 2021, I think, or 2021, I think. They start charging prices because, of course, they have their sustainability issues. So, just to end with, on the positive side, with something that may sound a little bit more optimistic. If there is a solution to this problem, a real solution, not a treatment of symptoms. So the solution is there. I'm going to argue is here. It's not there. It's right here, right now. And I'm going to argue that it's here. It's possible because there has been there already existing. There are some elements. The elements necessary for this solution are already there. One of them, of course, is the internet. Here we have Tim Berners-Lee, and the other is an example of the other is PsyArXiv. PsyArXiv was the first preprint server was created on the same year, 91, as the Berners-Lee's proposal for the World Wide Web was published. The same year, Paul Ginsberg from Harvard created the PsyArXiv, which is just a repository where all physicists, once they have their paper ready, they send it immediately to the archive, they publish it on the archive, and they don't have to wait for the whole journal thing in order to share their research with their world. So these things are already here. What is missing? And luckily, it's not just the archive. From 2005 onwards, we have a boom of open access repositories. Every university has its institutional repository. Actually, I don't think there is any university in the world that doesn't have a repository. I'm not sure, but it's most probably. I went and had a look and found the repository at NYU, which is called Faculty Digital Archive, and it's an open access repository. What is an open access repository? Here I'm talking about another, in Spain, we have the National Consortium of Science, the National Scientific Council, the Spanish National Scientific Council, it's a large scientific organization in Spain that has another repository, which is called Digital CSIC. And I'm talking about this particular repository because it's part of the solution that I'm going to propose. But where you see Digital CSIC, this could be, the role of this repository could be played by any repository, your own repository, and where you could perfectly do the same thing. Because what repositories are, actually they're publication platforms. Now we will see here, for example, the Digital CSIC, which is one of the European largest repositories. It serves 100 institutions. It has more than 130,000 open access articles, and it ensures all what we said that it's necessary for dissemination, for proper dissemination. So it's a perfect publication platform. It's a lot more efficient and more modern than what any publisher has to offer. Here's, for example, one article hosted on this repository. The title is not it's not accidental. It's one of the papers that we published with the repository manager of Isabel Bernal of CC. So here you see that you have all you expect from a publisher. You have your DOIs, you have your handles, you have your statistics, you have all these kind of ways to export. So I'm not going to try to convince you anymore that really repositories are actually better publication platforms than what journals offer. So knowing that we have the internet, knowing that our work is now digital, knowing that we have all these open access repositories, every institution has a repository, which is a perfectly valid publication platform. Back in 2010, we proposed a very specific model of how we could transform the academic publishing using solving the problem which we said is the mercantilization of knowledge, making the central element of academic publishing private companies or even non-profit companies, but whose main interest is sustainability, profit or sustainability. How can we solve it with what we already have, with public infrastructure and with voluntary academic work, which are the two necessary elements? So the idea is very simple. The authors, instead of sending their works to publishers, they send it to institutional repositories. So whenever your work is ready, you don't have to send it to any publisher. You just submit it to your institution, to NYU, for example, in the case of, in your case. So once it is submitted there, there is a way, there is a harvester, there is interoperability between these repositories. So it doesn't matter where actually it has been uploaded, because everything goes to the same, here, the same bucket, which we call the global open archive. So everything is visible from a single point, from a single portal on the internet. And here is where the peer review and the evaluation can happen. So this doesn't happen at the level of the journals, but it happens here, this global open archive. The journals, now we will see the evolution of this model now, where we have arrived with this model. The evolution of the journal is to facilitate these processes. So there is still a role for not journals as publishers, but journals as academic societies. So journals are really, they're not their publishers. Journals are usually a group of academics who are running and handling the journal. And these groups of academics can perform their peer review services simply not for a publisher, but for their public institutions. So if we have all these mechanisms in this model, then we can ensure these three fundamental processes that we discussed about. We have dissemination through the repositories. We have validation through peer review, but a peer review that we will see, it's kind of different when it's handled in this way, when there is no conflict of interest. And we can have also quantitative evaluation. So we'll show you now, I will end showing you a very clear example of how this can work. Here is an organization we founded in 2012 to bring together scientists that think in the same way and want to help us design and develop infrastructure and also promote these models. Here is our first attempt that was failed, but we learned a lot about that. We can see there's an interesting video here if you want to see it some moment later. And then in 2015, we created what is missing, as we saw, as what is missing from institutional repositories is the peer review service. The repositories are there, the content is hosted there, but there is no validation, there is no evaluation. So if we build a layer, an overlay layer of validation and evaluation on the content hosted in institutional repositories, then we have perfectly substituted the publisher, and that there is no added value offered really by the publisher. So that's what we did in 2015 with the funding from the European Commission. We built a module for open access repositories. Your repository, for example, at the YU could perfectly install this module and allow the researchers to review each other's papers, the papers that are hosted in the repository. In 2016, we teamed up with the Confederation of Open Access Repositories, which is an organization of repositories working under the same model, the same vision of bringing together, creating a network of repositories, the network that I described earlier in our model, and actually substitute, maybe you won't find this word there in their vision, but this is what is behind. It's actually the vision to substitute publishers with public infrastructure provided by institutional repositories. So here is another project that we run now with COAR, which is at the moment we're working on the infrastructure. So our group, Open Scholar, is working both on theoretical models. We're publishing and we're discussing ideas. We're giving talks, but also we are developing infrastructure. And this Notify project is still the technical elements missing, so that this thing can work together at a global level. And really now to conclude, I will give you the very specific example that I was mentioning. So here we have what is called an overlay journal. This is the idea of a mathematician, Tim Gowers, again one of the academics that was really frustrated by the system. He thought he had similar ideas like the ones I discussed with you now, and what he did was to create the first overlay journal. What is an overlay journal? You don't have to send the journal the paper, but you just have to send the link to the archive. So the paper, instead of sending your paper to the journal, you upload it on the repository. At the moment, the difference is that these overlay journals, whenever you hear overlay journal, they always work with a specific repository, the archive. So it has to be a physics or mathematics journal, because the archive only accepts this kind of content. So when you send the paper, when you upload the paper to the archive, you also send a link to discrete analysis to this journal. But when I say journal, think about it, not the publisher, but just a group of academics, and they will do the peer review. And what they will do once the paper has been accepted after the peer review process, they will simply make a mention, they will publish an abstract on their website, and then they will provide a link to the repository. So the publisher is the repository, and the peer review, validation, and evaluation service is happening at the journal level, which is just a web page called Discrete Analysis. That's the name of the journal. So combining these things together, combining the publication on the repository and the work of the editorial committee, you have all the services provided by publishers today. And now, last thing, we are building the first overlay journal. We started this idea in 2019, and in September, we're going to launch the first overlay journal, not on the archive, but on the institutional repository I presented earlier, the Digital CSIC, which is a public repository, has no sustainability issues. As you saw, it has thousands of open access articles. There is no scaling problem. There will never be any need to charge money, because it's publicly funded and it's sustained by the Spanish government. Like all institutional repositories, they are supported and sustained by their institutions. So the publisher is going to be this public institutional repository, and our journal Psicologica that has already has been around since 1998. That has an impact factor. It's a very traditional journal being published by a big publisher. It's going to abandon the publisher, and it's going to start publishing on the repository. So here is the workflow of how things will work. Again, as I discussed with overlay journals, you don't send to the journals. You send to the journal. You make a submission to the journal, but the journal submits immediately, uploads the article on the preprint server, and then after a round of reviews, it decides on to accept or reject. But this acceptance or rejection decision doesn't influence the fact that the paper continues to live here in the archive, in the repository, the paper and the reviews. Now I'm going to show you how the reviews work. Here is the journal, which is still under construction. In September, we're going to launch. Here is the front page of the journal, and here is the article the article view. And here's the review. So I really want to wrap it up. This is how we do review in our model. Okay, it's not just about getting rid of the publishers. The fact that we're getting rid of the publishers allows us to do things the way we want and not the way that is best for profit or for sustainability. So how do we perceive peer review? Peer review is not about deciding whether something is published or not, because it's already published on the repository. So it's just the peer reviewer is just there to help us, help editors and authors see if there are any problems, methodological mostly problems with the paper, and how these problems can be solved. So it's about creating, it's about offering suggestions for improving the scientific work. And the decision that the reviewer has to make is not whether to publish or not, as I said, or is just whether this paper meets scientific standards. And in case not, then they have to suggest, they have to provide a solid argumentation about what can be done to improve the scientific standards of the paper. And also reviewers are asked to rate the paper in other areas, for example, its importance for the field, general interest, social value, and an overall quality assessment. So this kind of metrics, quantitative metrics, can be used potentially in the future for evaluation and substitute the impact factor. Here we see, if we go here, I think it won't, if you, yeah, I'm not sharing internet, I'm just sharing one screen now. So if we click here, we will go to a paper. I will see if we can do that. Yeah, okay. So I'll finish sharing that. My conclusions for this topic. There is a conflict of interest. It's a very clear conflict of interest. I hope I convinced you about that, between the publishing industry and what's best for science. However, journals, they need not be published by publishers. They can be published by institutional repositories. By doing that, we can control the processes of validation, evaluation, and dissemination, and this will help us align these processes with the interests of science and society, not with profit and sustainability. And our effort, what we're going to launch very soon, Psychologica, is the first journal of a scientific society published on an institutional repository. And we think that it's a good example of what the future of academic publishing should look like. And if you allow me to stop sharing that, and I will share software here. And okay, so here you see an item on the repository, and you see, of course, the title and the abstract. And what you see here are the reviews. These are reviews of this paper. So here, this has been reviewed by this person, this scholar here, and this is another review. If we click inside the review, we get the full text of the review. So all these are items uploaded by the reviewer in order to try to improve the paper. You see that there are quantitative metrics. This is this takes you back to the original article, and here there is a comment by the author. So here is the reply of the author to the reviewer. So everything is kept, the reviews and the comments, the suggestions, all the track record of the process, of the peer review process, is becoming public, and it's totally undisclosed, the names of the reviewers and the conversation that went on between reviewers and authors in order to reach to the acceptance of the paper for the journal. So yeah, it took me a little bit more than I expected. I don't think we need to share my screen anymore. Just yeah, my last slide is this, which is the coffee that I would love to have with you now, if this was possible and this was a face-to-face meeting, and to continue the discussion. I hope I didn't exhaust you that much, and you still have time for and an interest for continuing, maybe getting into more details about any of the things that we discussed. Or I would definitely like to hear your own problems, your own ideas, your own issues. I try to present more or less everything that is going on, or at least I perceive that is going on. But maybe there are other things, maybe specific things that you would like to discuss. So I'm happy for that.
So hi.
Hi.
Thanks for the talk, and I think there are lots of things I would actually agree with, and especially this about like taking control more into like scientists' hand and societies and so on, instead of for-profit journals. Sounds very reasonable. One thing I wanted to ask about for a bit more detail is kind of the distinction between the the kind of gatekeeping part. Is this like solid science versus the evaluation, how interesting this is and how great of scientists the authors are? Because to me, this is very different from each other. Like, I would love to see it actually handled differently while you put these very much together into each thing. So so maybe I can just what are your views on the like separation actually between the two?
Yeah, I think I that's why I called two different processes: validation and evaluation. Validation would be the gatekeeping that you mentioned, probably like giving some kind of stamp saying that this is valid in terms of, I can imagine, methodology, right? Or it's reproducible, or there's accessibility to the data and code. So it's valid for, as a solid academic work. And the other is evaluation, which is what supposedly we try to measure through citations. So this is what you mean, right? These two different things. Yeah, so these are two different processes. And in the beginning, I said that we can use the same people. So the process of validation can help us also with evaluation, because if you think about it right now, how do we do evaluation? Whatever we use are proxies of quality. Citation, we assume that if something is cited, it's cited because it's good, right? Or we assume that if it's published in a journal that receives many citations, this article is also being cited, which is not true, as I showed you, because there's a skewed distribution. Most probably this paper, even if it's published in a big journal, it's not, maybe it hasn't received any citations. So instead of depending on proxies to quality, why not asking the reviewers themselves to provide some quantitative indexes? And so asking them, apart from saying if there are any problems, methodological problems with the paper that authors should look at, why don't we ask them also to give us some metrics? Even if you don't agree with this process, I mean, I believe it's better than trying to find indirect measures of quality. So that's why, for example, if you see our peer review form, the first question here, scientific standards, this is the validation. Is it ready yet or not? And if it's not ready, what needs to be done? And then we also have this part, which is about evaluation. So if somebody wants to assess the importance, but this is a totally different story. Validation is totally different from the importance, or if it's generally interesting, or if it has any social value, and this is the quality assessment, overall quality assessment of the paper. But this is just to help us have some kind of quantitative indices, which as I said in the beginning, it's a necessary evil. something that we need in order to rank authors. And I don't know if this, I see you still troubled.
Well, I think it's, I think in, like, first of all, yes, like, like counting citations there is in most cases stupid, and if anything, like a bad proxy, you can, a quick proxy to weed it out. But I have some hope that actually, like in actual application processes, people do a bit more than that, and actually, might read and check whether people are actually fitting for the things they are supposed to do. But I think it's like, I feel quite strongly that I would handle these two things very differently in terms of what they mean for a paper, right? So this first part is about something where I like intentionally like would actually want to have a hard threshold, right? So because there's no way that I could check for every paper someone else is citing whether that one is sufficiently high in the kind of things I want to do. And so like I feel like there is a collapse there where I would need an actual threshold, while the second part I feel more like that I can do my own, right? Like I wouldn't necessarily need an evaluation for actually on this at all. I would be totally happy to rely on what other people cite on the Twitters and sharing platforms and crawlers and whatnot to find out what papers are interesting to me, because these general evaluations are not particularly helpful even for that to me. There are lots of papers which are great, but I still don't care about that topic, right? So it's like, it's a very weak signal for actually whether I want to read that paper. So
yeah, I totally agree.
Yeah.
But my question is, are you talking from your side as an individual researcher, or from the side of a funding agency or university that needs to hire somebody for the department? I mean, what do we do with this situation? Because yes, I mean, for individuals, yeah, I agree with you. That's how I do it as well. I'm doing the work myself to see if something is interesting or not. But what do we do with this process? That's, I think, the crucial thing.
Well,
for me,
I don't want to take over the whole discussion. So
no, okay,
but just to say that I would actually expect something relatively similar, that in most cases, at least when there is a weighty decision to be made, that people would actually check what kind of papers people have written, and like
exactly,
and so these things would similar as now, like maybe I would agree it's probably an improvement over like counting citations, but in the end it's like an earlier hurdle, and hopefully people would look at more information about them anyway.
I think it's impossible to disagree on that the ideal way to evaluate something is by as close contact as possible, like really read the papers yourself if you want to decide who to hire or who to give the money to. So ideally that would be the way to do that. My experience is that it's not working this way, and so that's why I'm calling it necessary, something better than what we have now. And as for the first part, it's what we propose is this threshold that you mentioned. It's absolutely necessary. So what we propose is, instead of the threshold being the publication in a journal with a name and an impact factor, instead of that, you access the paper and then you see a list of academics with names and knowing who they are, they endorse the paper, and they have said that this is good. I mean, and an editorial team that, based on these reviews, has passed the threshold for this editorial committee, so it appears on the front page of the journal. But this is not a prerequisite for publication. It's public, but it can be public with no endorsements, but it can be public with very specific endorsements for very specific people who say, who made their opinions and their argumentation public through and linked to the article. So this is our idea of this threshold. So there needs to be a threshold, but it needs to be open and transparent. This process needs to be open and transparent, and not depend. Your threshold should not be oh, okay, it's published in Nature, so it must be good. So this is what we don't agree with. But of course, we need approval, but it needs to be open and transparent. Anyone else?
Hey, I'll ask a question if no one else does. So
Okay.
thanks for a great talk. That was very informative. So you talked about briefly about how market economics are applied to knowledge sharing and how that may lead to this competitive behavior, and that creates some incentives that may lead to fraudulent behavior or other things like that. So to me, that's a very core part of the argument for why this system should change. So has there been experimental research that supports this idea in psychology or economics?
That supports which idea exactly?
That there's this competition and that will lead people to have do some things that are against the interest of the larger
But I can think of surveys. There have been a lot of surveys. I'm not sure if it's focused on psychology, but I'm aware of different surveys. I can look them up, where scientists have been asked about their publication practices and research practices. We have launched some of these surveys ourselves, and what conclusions do we draw from this? There are people, for example, the papers that I showed about misconduct, they're also from surveys. So scientists, when it's obviously anonymous, they admit that they have they also had this kind of behavior. So I don't know if this is the kind of experimental evidence that you were asking for, or if it's something more solid than just surveys and what scientists say. But this has been, I mean, all these ideas about misconduct and about how people are gaming the system and trying to game the system, this is coming from scientists themselves.
Okay. That helps, yeah.
I have a quick question if we have time.
Hi, yeah.
Hi, thanks for the great talk. Super interesting, and I agree with almost everything you're saying about the issues and potential solutions. One question that I have is, how do you plan to onboard people onto this idea? It's obviously very big picture. I think a lot of scientists would agree with the values that you're trying to instill here. But to sort of transition people into this new mode of thinking it sounds like a big challenge. And so I'm wondering how you're thinking about that. Yeah,
this has been this is a big issue, because we started in the beginning, we started from zero, from scratch. We built actually the video I didn't show you. If you have a couple of minutes to watch it at some point, it was publicizing a new platform, inviting researchers to come and do things in an ethical way. So this doesn't work, and it's not just us that we tried it. Other people have tried it as well, and hasn't reached the critical mass to make it really powerful. So the current idea, that's why I'm very happy about this project that we're going to launch in September, is actually continue with the idea of a journal. So it's still a journal. It's still something people recognize. We don't ask them to do something really weird. We're just asking them to send their papers to the journal. The journal is totally free, so you don't have to pay for open access. It's obviously open access, but it's free. So there you have an incentive. The journal has an impact factor. So for those, we understand that impact factor is crucial. So it does have an impact factor. It's like any journal. It's not very high impact factor for the field, but still as an incentive, we have that as well. But the idea is that we're doing everything differently. So it's a journal. People don't need, you don't really need to submit your article there if you're an idealist or anything. You do it because you would do it anyway. It's a journal that already has articles. But what we're trying to show is that we have a journal that costs 1,000. The entire journal costs 1,000 euros per year. That's the cost, because the publication is happening at the institutional repository. We're doing open peer review. So we're acknowledging reviewers, all these positive things that we think that open peer review comes with. And this is happening. So really, we're not asking anything. We're not asking people anything. We're just showing how this can work. So if we ask anything, is other scientific societies who run journals to use our model. So it's not asking individual scientists anymore. It's like our marketing style, let's call it marketing, from now on will be to approach scientific societies that own and run journals, and they need publishers. So they're like stuck with a publisher that it's exploiting them, it's charging a lot of money. So we're gonna say, why don't you move your journal to public infrastructure? Why don't you make a deal with a repository? Repositories they want that. They want more visibility. I mean, I've discussed with librarians. Part of what we do is collaborate with the librarians, and they want to host journals. They just haven't thought about it because researchers are so obsessed with journals, and they never thought that they could be the publishers. It's really as simple as that. So now we're offering a new paradigm. It's like scientific societies, they get together with institutional repositories, and there you have your journal. From the side of the individual researcher, nothing changes. But of course, you're gonna have to know that this journal works in this way. This is an overlay journal. This is the name that is being used now. So this means that if I have to choose between two, I'm not asking, especially early career researchers, I'm not asking them to submit their journals to their work to ethical journals. I'm asking them to do what's best for their individual careers. Maybe I can ask, people who are researchers who are already, solved their life problems to help, like for idealistic reasons. But what we are asking is if you compare between two journals with the same prestige or same impact factor, well, choose this option because it's supporting a transition to a different model, a more ethical model, and more efficient model for science, for what science is supposed to be about. So I don't know if this has been with this project that we launched now for the first time. I think there is a solution to the problem that you mentioned.
Yeah, I agree. I think it creates less friction when it's just a platform, and then you have it, the same sort of structure on other publishers' websites and so forth. Yeah. So
exactly. Yeah.
I have some more questions if no one else.
Yeah, go on. And I'll have, yeah. No, go on. And maybe I have one question later for all of you.
So I'm wondering, like you mentioned earlier in this new, I guess you would call it overlay journal, Psychological.
Mm-hmm. Yeah.
So you say that the paper, of course, will stay in the repository after a rejection, but does it stay on the journal website? Where's the record? Is the record in places of the reviews?
Sorry,
what's record of the reviews and the rejection, but does that stay on the journal site and the repository site, or just
no, the journal doesn't keep anything. The journal doesn't publish anything. Everything stays at the repository if it's not accepted by the journal. So this means that you have like a preprint, like the preprints we have now, but on top of these preprints, you also have the reviews. So the author has the possibility of using these reviews if they want. So if they want to submit to another journal, they can send the whole package of reviews. This is up to the authors if they want that. And the reviewers, the work of the reviewers doesn't depend on publication or not. So you already, even if the article that you reviewed is not published, you have your DOI, reviews have DOI. You can use in your academic record the fact that you have reviewed this article. Okay. So publication is really less meaningful than it is in this model. It's not publication. It's just the endorsement of the journal that is happening at the journal level.
I see. And another question I had was, so you're going to have these new metrics essentially that will be made public about, in these different dimensions like general interest and so on.
Mm-hmm.
So is there evidence that those types of experimental evidence that those type of metrics agree with each other better than the binary decisions? Because you showed that the binary decisions are at chance.
No, there can't be an experimental research because we don't have the metrics yet. So obviously we want to keep track of how this works and publish results as soon as possible about this. But this evaluation part is it's very an early stage. It's a very experimental stage, and obviously we want to see how it works before we can make any strong statements about its usefulness. But we don't have yet because it hasn't started, it hasn't launched yet.
I see. So, and then another thing that came to mind was there's this set of papers about prediction markets for reproducibility, and basically showing that academics can make some judgment about whether a paper will reproduce at the time of a review, and that has some predictive value that's above chance. Have you seen that, or like that? Yeah.
I'm not sure I've seen that.
Okay, I could send it to you.
Yeah, please do. Okay.
So if academics have some idea about how reproducible paper is, but that doesn't necessarily align with what their decision might be or something. So there's some information there that might be useful.
Their decision as what? As authors?
Their decision as a reviewer. So if they're
as a reviewer, yeah.
Paper, even though it's not reproducible. So there was just a paper in Science Advances, I think, that shows that actual papers that are less reproducible get accepted more or something like that. Yeah. So that along with that, academics can predict the reproducibility of papers, but that they don't necessarily reject those papers as reviewers.
Yeah. I can see why this happens. Of course, I can see why this happens because the acceptance criterion is not based on reproducibility; it's based more on attracting citations. So, reproducible but very not so exciting topic may be rejected, but some a sexy topic with very small statistical power can be published. And we know there's some evidence. There are papers published showing that publications in high impact factors are less methodologically rigorous because these journals are the ones that are after the big news rather than methodological soundness. So there are data about that. That impact factor doesn't correlate not either with reproducibility or methodological rigorousness.
Yeah, and I don't see that as, I don't see that as a big problem necessarily, but just that there's some information that the reviewers have that the binary acceptance decision isn't capturing could be useful. Like, yeah. I don't know.
And I mean, ideally, I think that part of the reviewers' work could be to test reproducibility. I mean, I can imagine a workflow where data and code is shared together with the article so that not just reviewers, but anyone can easily try to reproduce at least the part, not the part of the methodological part, so that reviews come with the reproducibility test. This could be, but of course, reviewers now in the current system, they don't have incentives to provide more lengthy and thoughtful reviews. It's just a burden that they have.
Yeah. And one other thing I was wondering is, you mentioned at the beginning that, many reviewers would be ideal rather than 2 to 3 reviewers. So I'm wondering, at the overlay journals, that you're proposing, how that works, and how you would incentivize many reviewers to get involved, or how that would work.
Yeah, one thing that as an incentive, we think that this can work. There are surveys again that show that there are many researchers that would be incentivized by publishing the reviews. That publishing reviews would be an incentive for many reviewers, and we can think of many reviewers. It's also another change of paradigm is that we think of reviewers nowadays reviewers receive an invitation to offer an overall assessment of the entire paper. So we can think of reviewers being invited to provide an expert opinion for specific aspects of the paper. So for example, if I'm using an algorithm, I can invite the person who invented the algorithm to tell me if this has been applied correctly in this case, but I will not ask him if my references are right, or if my interpretation is correct, or if my introduction is concise. So just asking you to have a look at this. So I can have more reviewers looking at specific parts of the paper. So I can have a validation by really more people and more experts for the different areas of the paper. So this is kind of things that we want to promote in this journal.
I see. That's interesting.
So maybe a review can be fast and precise. So reviewers sometimes they think that review is very, you have to read an entire paper. Maybe it's not even that. Just look at this equation. Look at this model. Is it correct? And maybe this half an hour job, and you're already a reviewer, but it's very clear that this is what you have reviewed. You have no opinion about the rest of the paper, and then we would look for other people for other parts of the paper. So these are things that we want to introduce now.
Do you see peer review as being always necessary? I mean, is there an opt-out? Like, you presented this Einstein quote, but now you're saying like there is peer review. So
yes, no, there is some necessity for this. We talked about it with this threshold. No, so how do I know? We had this now with the pandemic. We had all this boom of preprints, and journalists, they were picking preprints and they were publishing them as research already published, and because it's not clear yet to the public the difference between a preprint and a postprint. So we need some kind of quality insurance. There have been attempts to skip that altogether. So you publish everything, and then anybody is responsible for what they read and what they use. This has been also proposed, but the way I see it, and from discussions and from where I see that things are going, I think that we cannot get rid of peer review, at least yet. We need this kind of validation process because it's too much production out there. There's a lot of research, and we kind of depend on this service at the moment, at least. That's what I think. I don't know.
And what about reviewing reviewers, which does happen at some conferences and so on, and I think can work well? Yes.
The original model now, this module that is working in the repository, it has an extra step of reviewing of the reviewers. So any user of the repository, which is a member of the society of the institution, like if it's your institutional repository, you have to be logged in through your academic credentials, so they can review also the reviews. So this is enabled. This exists as an idea, and we have also weighted metrics. So the reviewer, the weight of the review on the paper, on the overall assessment of the paper, depends on the ranking of the reviewer, or the metrics of the reviewer. So there are weighted metrics based on reviewer's reputation. So we have this already, but I don't think we're going to implement it on the journal, at least at this first stage, because I think it's too much. I think too much to digest as a first approach. There are many ideas that we can try to implement slowly. And the good thing is that we can do whatever we want because there is no pressure from funders or from, we are just a society of researchers, of scientists, with our only interest we don't have issues of sustainability. We don't have issues of profit. We're just going to experiment with what we think is best for doing things right. So, but we don't want to start like throw it all immediately at the first stage. But yeah, these are some of the ideas that are already there and probably will soon be implemented.
Okay.
So I wanted to ask you, I don't know if you people, I mean, one serious problem that we have, at least here, is like where to publish. So there's a lot of pressure of publishing in open access journals. So I don't know if the people who are left, at least now, if you're students or if you are at which stage of your career you are, and if you have any freedom in where you publish, or if somebody decides for you, maybe your group leaders, or how is this the decision on where to publish? And now we have this idea of you have to pay to publish, you have to publish to open access journals, or what is the strategy? How does this happen? Are you free to choose your journals? And if you are, how do you make this decision?
So, well, I mean, so I'm a postdoc here, and I think it's yeah, like in principle, I'm quite free for to be discussed, of course, with the PI. So with Waity, we would discuss about it, and yeah, I mean, in theory, we don't have much of an obligation where it goes, I think. For grants and stuff, I think there is a pretty clear thing that it has to be actually published. So like in a peer-reviewed journal, so there is like depending on the grant agency, there might be slightly different lists for this, but essentially you need it needs to have this ominous stem. And realistically, there is just a fairly short list of journals which you know, where most of the stuff we read is published in. So I mean, there's maybe 10 in total or so. And you know, then
but is
like it's mostly topic actually which decides which paper goes to which journal.
Is there a mandate or a pressure for open access, for the journal to be open access, or it doesn't matter? Because some funders, they already ask for that, and you haven't had that problem.
We haven't had that problem very much, and I think for the NIH, it's like they just force you, whether it's open access or not, you are allowed and forced to upload the papers to the NIH portal, and at some point they just publish it.
Okay. No, I think it's what many people don't realize, and I think this is very important, is that open access is not just paying gold open access, like paying for the journal. So I hear many people or many young researchers now saying, I have to publish to an open access journal, but there are no mandates there is a recommendation, but you can also accomplish open access by uploading it to a repository. So you can continue to publish wherever you like, actually. You're not forced to choose an open access journal, and you're not forced to ask for money, for project money, to be for open access publications. And there are many of us here who are trying to convince people not to ask for budget money, not to ask budget money for publications, and redirect this to other more important aspects instead of spending them for publication.